Today our topic is refining of metals. As you know that our main topic is metallurgy. We have completed two steps of metallurgy. First one is concentration of ore and second is extraction of metals. And extraction, we do extraction of less reactive, moderately reactive and highly reactive metals. So what is refining? It is the last step, it's the final step of metallurgy when we obtain metal in free state after its extraction. That metal is not 100% pure, just like our last topic was electrolytic reduction of sodium chloride. From that very method we obtained sodium in free state or in elemental state. So that sodium is not 100% pure. It contains, or every metal when they are extracted from their ores, the metals are not 100% pure. They contain some amount of impurities, and impurities may be in the form of impure metals. That metal which we extracted, that may contain some mixture or some amount of other metals with it. So in this method we have to remove those impurities of the other metals which are present in the metal that we extracted in the last method. So what is refining? Refining means the process of purifying impure metals after their extraction. The process by which we purify an impure metal after it's extracted from its ore. This method is called as refining of metal or purification of metal. Like when we extracted sodium from sodium chloride, or when we extracted copper from copper sulfate. So this sodium or this copper, they are present in free state, they are in elemental state, but they are not 100% pure. For instance, copper, when we extract it from its ore, that is copper sulfate, this copper contains some amount of impurities. The impurities are not like insects or microorganisms or leaves or sand or anything else. No, the impurities are present in the form of other metals. Like it may contain some amount of gold, it may contain some amount of silver or iron. Little amount of this copper may contain some amount of the metals of these the impurities of these metals. So how can we remove these impurities from this metal? How can we obtain copper, 100% pure copper? So we will study it in the refining of metals. So refining means purification of impure metal after it's extracted. So how can we refine metal? It depends. The refining of metal depends on the nature of the metal as well as on the nature of impurities, because impurities are of various types. In the same way, metals are of various types: highly reactive, least reactive, and moderately reactive. So most important, there are a large number of methods by which we can purify a metal. Most important and most widely used for refining is electrolytic refining or refining by electrolysis. You know what is electrolysis? Electrolysis means splitting of a compound by the passage of electric current. When we pass electric current through a molten state or through an aqueous solution of a compound, it gets split, it gets broken into its ions. This whole process is called as electrolysis. So here we will study the electrolytic refining of metals. Important metals which are refined electrolytically are copper, zinc, lead, tin, chromium, nickel, gold, and silver. These are some metals which are refined electrolytically. So, electrolytic refining, you know that for electrolytic refining we need an apparatus, and that apparatus is shown here. It is an electrolytic tank. We need two electrodes, positive electrode which is called as anode and negative electrode which is called as cathode, and these are connected to a battery. We need, so in order to refine electrolytically, for instance, we have to refine copper. We will study the electrolytic refining of copper. So what are the conditions required for electrolytic refining of a metal? We need a thick block of impure metal, the metal that we extracted in the last step. We need a block of that metal, and it is made anode. The impure metal is made anode. You will see here, this is impure metal and it is made anode. Number second, pure pure metal is made cathode. Both are same, copper. This electrode, positive electrode as well as negative electrodes, are made up of copper. Different lies that the anode, which is positive electrode, it is made up of impure copper, and the cathode, which is negative electrode, it is made up of pure copper. This is the first and second condition required. Number third is, we have to fill the electrolytic tank with an electrolyte, with a solution of electrolyte, for instance. But the solution must be, here you will see, third step, a water soluble salt of the metal to be refined. A salt solution of the metal which is to be refined. Here we have to refine copper, so we will use a salt solution of copper, for instance copper sulfate solution. So we have to make an acidified means, in copper sulfate solution we will add some amount of acid. That acid may be hydrochloric acid or sulfuric acid. It is used as an electrolyte in the electrolytic tank. What is an electrolyte? Electrolyte is the aqueous solution in which electricity can pass. So we need three substances for electrolytic refining of copper. We need an impure block of copper that we extracted in the last step. We need a thin strip of pure metal or pure copper, it is made cathode. And we need a solution of copper. It can be copper sulfate, it can be copper chloride, it can be copper nitrate, any electrolytic solution of copper. So here we will use copper sulfate solution. So what will happen after this? These two electrodes are different in size. Anode is thick and cathode is thin. What is the reason behind that? Just look at this. Anode is impure copper. We have to convert this impure copper into pure copper. Cathode is pure copper. So when we will pass electric current through this electrolytic solution, through this acidified copper sulfate solution, here three reactions will take place, and the reactions will take place simultaneously. Simultaneously means at the same time. The reaction in electrolytic tank, at cathode and at anode, it will take place at the same time. So I will show you step by step how the reactions will take place. At first I will discuss about the reaction that will take place in this electrolytic tank in the acidified copper sulfate solution. When electricity is passed through this solution, splitting of copper sulfate solution will take place. For instance, this is copper sulfate solution. It will get split into copper 2 positive and sulfate SO4 2 negative. This is the electrolysis. This process is called as electrolysis. Copper sulfate solution will split into copper ion, copper cation and sulfate anion, Cu2 positive and SO4 2 negative. This is the reaction which will take place in the electrolytic tank. Number second, as you know that anode, it is impure copper and the charge of the anode is positive. Anode is positively charged. Positively charged means it is short of electrons. It needs electron to become neutral. So this impure copper will, it is neutral. Copper is neutral and its valency is 2. So the copper from anode, the impure copper which is made as anode, it will lose 2 electrons to the anode. The impure copper which is made as anode, it will lose 2 electrons because its valency is 2. It will lose 2 electrons to the anode and its charge will be Cu2 positive. Just note it down that the impure copper which is made as anode, it will lose 2 electrons to the anode and after that it will mix in the solution. This copper sulfate will mix in the solution and this anode, it is thick. With the passage of time, the anode, the positively charged electrode, it will become thin. When this copper will move in this solution, from that very solution, as you know that copper sulfate is already split into its ions Cu2 positive and SO4 2 negative. This copper ion, Cu2 positive ion, it will move towards cathode because it is positively charged. It is cation, and cation or positively charged ion always moves towards the electrode which is negatively charged. The copper ions will move towards cathode. In the same way, the impure copper, after losing electron, it will get converted into copper Cu2 positive and will fall in this solution. From that very solution, these ions will also get attracted towards the cathode, towards the negatively charged electrode. Here you will see at cathode, copper goes towards cathode and gains electrons and get reduced. I will show you here. For instance, this is electrolytic tank. These are the two terminals. This is negatively charged electrode and this is positively charged electrode. This is cathode and this is anode. It contains copper sulfate solution. This solution is copper sulfate solution. It contains impure copper, and this impure copper, when it loses electron, it gets converted into Cu2 positive. This solution also contains Cu2 positive and the copper ion will move towards cathode, that is negatively charged electrode. So here at cathode, this is cathode, copper ions will move towards cathode, towards negatively charged electrode. So copper ions, when they move towards cathode, there are two types of copper ion. First one is from the copper sulfate solution. The second one is impure copper. When after losing its electron it goes into the solution, and from that solution it moves towards cathode. It means at cathode is having negative charge. The copper ions, as you know that they are short of electrons, so at cathode Cu2 positive, they will gain electron and will get converted into Cu, copper metal. It will gain 2 electrons. And at anode, copper atoms of the impure anode lose 2 electrons each to anode and form in this way. It is at anode Cu minus 2 electrons, and it will get converted into Cu2 positive. That means on anode oxidation will take place, and at cathode reduction will take place. So with the passage of time, this anode electrode, it will become thinner and thinner, and the cathode will become thicker and thicker, because the impure copper goes away from the anode and it get stick it to the cathode. So on cathode, on the negative terminal, we will get copper in the form of copper metal in pure state. After that, what happens to the impurities that were present with the copper metal? The impurities that were present in this copper metal, there are two types of impurities. Some impurities are highly reactive and some impurities are least reactive. The highly reactive impurities, as you know that this solution contains sulfate ion. It contains sulfate ion. The highly reactive impurities will react with this sulfate ion and form compound in this electrolytic tank, and the less reactive impurities, for instance gold and silver, they will be collected at the bottom of the anode, and that thing is called as anode mud. So there are two types of impurities: highly reactive impurities, for instance if this copper contains some highly reactive metal, that is sodium, this sodium will combine with this sulfate solution and it will form sodium sulfate, Na2SO4. But the least reactive impurities, for instance gold or silver or platinum, they do not react with this sulfate solution. They will be collected below the anode, below the positive terminal of the battery, and that is called as anode mud. So from this method we came to conclusion that the electrolytic refining is very important in two ways. First one, it refines or purifies the metal concerned, the metal that we require, it purifies the metal. And number second, due to this very method we are able to recover other valuable metals like gold and silver. So it is having two advantages. First one is it purifies the metal and it recovers the other valuable metals. This was the electrolytic refining of copper.